Hello, everybody. Today we're going over factoring and solving polynomial equations. And our biggest vocabulary or key term is this idea of to factor completely. And when someone asks you, or if the book asks you, or I ask you to factor completely, that means you're going to factor the polynomial until it cannot be factored any further. Okay, so let's say you factor something once. If the remaining one of two or however many of the factors can also be factored again, keep going. Okay, so hopefully this graphic looks familiar to you, right? Last chapter we went over factoring for 2 terms, 3 terms, and 4 terms. Okay, remember that for 2-term factoring, we looked at a difference of 2 squares, where it was some form a squared minus b squared equals, and then we said it was a difference, so 1's plus 1's minus, of 2 squares, meaning the 2 terms are almost identical, but there's a minus and a plus in the middle of each. And then secondly, we talked about if there was a trinomial, meaning 3 terms, if there were 3 terms, and the a value was 1, we would use the x factor method, where we would make our big X, we put our value of c on top, value of b on the bottom. We'd figure out the 2 factors that multiply to c but add to b, and then we'd set up our factors x minus, and put our values for m here and n here, and that would be our factor. We also talked about factoring a trinomial where the a wasn't 1, but it was bigger than 1. So if we knew that the a value was not 1, we did this x grouping method, where we would write our x, and at the top we'd put the value of whatever the a, and actually this should be ax squared, sorry, not a squared, but ax squared. And then we would put the value of a times c at the top and the value of b at the bottom. Whatever 2 numbers would multiply to ac and add to b would go here and here. But then that grouping meant we had to split the middle term. Instead of bx, we're changing it to mx and nx. You brought down the ax squared and the c, and then you would group the first 2 plus the second 2, and then you pulled out a GCF for each, okay, where you ended up with this factoring thing, where we would have a matching GCF, and then we pulled it out again. So then it would factor down to whatever that GCF was, and then these 2 terms, whatever they were left with would go here. So hopefully that's just a review for you. If you need more help with that, come see me. And then we haven't gone over this one yet. We've kind of gone over it because of X grouping, but grouping is if we have 4 terms. Oh, okay. So grouping is if we have 4 terms. And so, for example, if we have ax cubed plus bx squared plus cx plus d, we would take the first 2 terms and group them here, and we would take the second 2 terms and group them here. And then you'd pull out a GCF of both of these terms, which in this case, would be x squared, which you'd end up with ax plus b. And this GCF, there isn't one. So, but anyway, you'd go on from there, which is a lot like the last steps of the X grouping method. But the last one that we need to learn for today is called the sum and difference of 2 cubes. And the thing that you need to remember about this is the term SOAP. And here is why. If we recognize that we're having to factor a sum or a difference, meaning a sum is an addition and a difference is a subtraction, of 2 cubes, meaning some number cubed plus some number cubed, okay? So they could be variables, they could be numbers, and we'll write off a list of cubed terms to the side over here. But here's what the formula or the form goes for a sum or difference of 2 cubes. We factor this out to 2 terms. The first one is a binomial, the second one is a trinomial. And we basically take a cubed and b cubed. We have to be able to write it in this form of some value cubed plus some value cubed. And you'll see why we're doing that as we do our examples. Whatever this term is right here, we're going to put that here. We're going to put that here, okay? And then whatever this value is here, I'm going to put that value, or a squared, right here. And then I'm going to put 2, whatever both of these terms are, 2a times b in the middle. And then we're going to go b squared at the end. And now here is where SOAP comes in handy. SOAP just stands for, we're talking about the signs. We're looking at this sign here, and we've got a sign to fill in right here, and right here. So we go same as this, opposite, so that's in this one, opposite of plus is the negative, and then the last one is always positive. So we set it up as whatever the first term cubed is, we go a, whatever the last term cubed is, b, first term squared, a squared, 2 terms multiplied together with a 2 in front, 2ab, and the last term squared goes here. And then we go same sign, opposite sign, always positive for the signs. Let's do the next one. Oops, and this is actually miswritten. This is supposed to say a cubed minus b cubed. And again, we're going to set it up the same way, where we know a cubed is really just a cubed minus b cubed. And we're going to put a, b here, a squared, 2ab, b squared in that pattern. And then we're going to go same, opposite, always positive. So what that SOAP stands for, the positives and negatives in the sum or difference of 2 cubes. So if you still have your factoring graphic organizer, go ahead and pull that out. Add this to the side or the back or a separate piece of paper, but you're definitely going to want this to be in your notes and on that graphic organizer, okay? So that's our little review of factoring. So we have to kind of keep all of those in mind with our factoring. Now remember, our first stop for factoring rules is always check for a GCF, right? All my football players. Hopefully you can hear that in your brains when you talk about factoring. So in order to factor completely, which means don't stop factoring until you can be done. So I'm going to look for number 1a, GCF, and we see that every term has an x. So we're left with, well, I know x cubed divided by x is x squared, so that's what goes here. 2x squared divided by x gives me 2x, so that's what's left here. And negative 15x divided by x is just negative 15. So that's what we have. And then we're going to see, well, can this be factored again? We can see that there's 1, 2, 3 terms. And in those 3 terms, there's this a value of 1. So we're going to use our x factor method here. Okay, so here's our x. We put our c term on the top, b term on the bottom. What 2 numbers will multiply to 15 and add to 2? Well, I know 3 and 5 can make 15. If this is negative, one of those values have to be negative. but they have to add to 2. So I'm going to make the smaller one negative and the bigger one positive. And we can double check it. Negative 3 times 5. Negative 3 times 5 is negative 15, and negative 3 plus 5 is positive 2. So perfect. So this becomes x, and then we put the terms, or the factors here, minus 3 and plus 5 here. And then don't forget to bring down this x out in front. And so this is completely factored because none of these terms can be factored anymore. All right, let's do the next one. I'm going to make it a little bit bigger. All right, again, step 1, we always look for a GCF. I see both of them have a 2 that we can pull out, and they both have a variable of y, and the smallest exponent we see is 3. So I'm going to pull out a 2 and a y to the 3rd. So 2y to the 5th divided by 2y to the 3rd, the 2's cancel. And remember by our power properties that when we have a quotient of powers, we're really subtracting them. This becomes y to the 2. So we leave this here, bring down the minus sign. And we're left, then we have to figure out 18y cubed divided by 2y cubed. The 18 and the 2 reduce to 9, and the y cubed cancel. So this is just 9. And hopefully you can see, well, are we still done with this? The answer is no. So we have 2 terms remaining. So now we look at the number of terms. If there's 2 remaining, remember, this is a squared term, minus 9. So if we're looking up here for 2 terms, it could either be a difference of 2 squares or a sum or difference of cubes. We definitely know it's not a cube because we're dealing with our biggest exponent is x squared. Let's see if it's a difference of 2 squares. Now, here I know that y squared is definitely a squared, but also 9 is a perfect square. So we know if we've got a difference of 2 squares, we can set up our factors. We have y and y, the root of 9 is 3 and 3, and they're a difference of each other means 1 is positive, 1 is negative, and then we bring this one down. We'll put it in its own parentheses. So that is our factors, and we used a difference of 2 squares to factor this completely. All right, let's look at this one. We've got x cubed plus 64. Now, again, this is 2 terms. This is a cubed. I know that the only possibility if it's 2 terms could either be difference of 2 squares, which it isn't a square for sure, or it could be a sum or difference of 2 cubes. So here's how we would figure this out. Oh, by the way, did we check to see if it was a GCF? GCF. There isn't a GCF here, so we can move on to the number of terms, which we just kind of looked at. There were 2 terms, but this is a cube. So the only way that this could work is if this was a sum of cubes. So we're going to look to see if it's a sum of cubes. So basically, in order to see if this is a sum of cubes, we have to make sure that it's in the form of something cubed plus something cubed. Well, I definitely know that x cubed is like saying x quantity cubed, but is 64 a perfect cube? Let's check that. So I know if I've got my list of cubes here, or some x cubed, I know 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and so on. But look at that. Woohoo! 64 is 4 cubed. So because it is in that form of a sum of cubes, I can use this form to factor it down. Remember, SOAP, a squared, 2ab, b squared. So we're going to set that up. Here we go. So we're going to set up a binomial times a trinomial. We take our a term, goes here. Our b term, which is 4, goes here. Our a term is squared in the front of this, and then we put 2 times both of these terms, so 2 times x times 4 And then we have this last term squared goes here. And then we go SOAP, right? So remember, SOAP stands for same sign, opposite sign, always positive. So let's simplify that a little bit. This becomes x plus 4, and then we have x squared. Negative 2 times x times 4 is 8x, and 4 squared is 16. And then let's see, can this factor? Again, are we completely factored? So this, we're good, we can't factor it anymore. What about this? Well, yeah, we could actually factor that again. There's 1, 2, 3 terms. If there's 3 terms and there's a coefficient of 1 here, we're going to put the 16 on top and the negative 8 on bottom. I know that negative 4 and negative 4 will multiply to 16 and add to negative 8. So we go like this. If we're factoring 3 terms, right, x factor process, and we've got x and x go here, and minus 4 and minus 4 go here. Bring down this factor. And then to write this, because both of these are the same, I can write this as x minus 4 squared because it happens twice. So this is our complete factorization. All right, let's look at this one now. This is 1, 2, 3, 4 terms. There's no GCF, so we already covered that. There are 4 terms, which means we're going to have to try grouping. So here we go. We're going to put a parentheses around the first 2, put a plus, and around the second 2. And now we're going to pull out a GCF of each of these. So the GCF of x cubed and 3x squared is just x squared. And we're left with x minus 3. Bring down this plus sign. And the GCF here is actually this negative 16 we're going to pull out. And we end up with x minus 48 divided by negative 16 is actually negative 3. Now look at that. Aren't we excited? Congratulations, it's twins, right? That's what we're hoping to see. So this gets pulled out as its GCF of both the left and the right-hand side. And then what we're left with is x squared plus negative 16. And that's going to go right here. Now the question is, again, are we fully factored? We can see here there's 2 terms and they're both perfect squares. So again, there's no GCF. We can factor this down to a difference of 2 squares where we put x and x, 4 and 4, 1's a minus, 1's a plus. And that is our full factorization. All right, next example. Now, okay, this one's tough. There's only 2 terms, but none of them are a squared or a cube, right? Or is it? So let's just look at this. This could be, so number 1, we always look for a GCF. There isn't one in this case. 16 and 81 don't have anything in common, but are again, for the number of terms, there are 2 terms here. Now, this is definitely not a cube, but could it be a difference of 2 squares or difference of squares? Let's see. If I can put this in the form of something squared minus something squared, I definitely know 81 is 9 squared. Well, 16 could be 4 squared, and x to the 4, couldn't that be x squared? So actually this is a difference of 2 squares, okay? So when I set this up, I'm gonna go 2 parentheses, 1's a plus, 1's a minus, and we're gonna put whatever's inside here. 4x squared goes here, and the 9 goes here. Now, this is definitely, you cannot factor it anymore, but this actually could factor again. And that's because it's another difference of 2 squares. I know 4x squared is really 2x times itself, and the root of 9 is just 3. And then we go 1 is plus, 1 is minus. So when we're factoring completely, we might have to do it more than once and definitely check everything again.